Greetings of the day, dear students, and in this AC circuit analysis, okay, we will see the representation of a sinusoidal waveform. And in this video, we will discuss the mathematical representation of a sinusoidal waveform, mathematical equation, how we will represent that, and also we will see the graphical representation of a sinusoidal waveform, and we will discuss the amplitude, angular frequency, and also the time period of a sinusoid, and we will look at some examples where for a given mathematical form how to find out the amplitude, phase, period, and frequency, and we will see the definitions of phase and phase difference. You will understand the phase and phase difference, and some basics of sinusoidal and cosine term. Okay, yeah. Now coming to the representation of a sinusoidal waveform, it is nothing but a signal, right? Yeah, that has a form, any signal that has a form or of sine or cosine function is a sinusoid. It is important to understand that sinusoid does not mean that only sine wave. The cosine wave, the sine and cosine together, we can call it as a sinusoid. That means sin omega t is a sinusoid, and also cos omega t. Both are both comes under sinusoid only, right? Why these two are very important sinusoidal form? While dealing with the AC circuit analysis, the voltage waveform, the voltage or the current, okay, will be an alternating quantity, and more specifically it will be sinusoid. If this is the voltage which is a function of time, on x-axis if you have taken time, this represents a alternating quantity which is of sinusoidal in nature. And there is one there are different types of alternating quantities. For example, this is also alternating quantity only. This is also one type of voltage waveform, but this is a pulse. And if you observe, this is one more voltage waveform. This represents a DC. It is not depending on time, it is independent of time, some voltage. So in order to represent the alternating quantity of a sinusoid, we will be dealing with this one, right? Yeah. Now if any voltage which is of mathematical form, v of t equals to Vm sine of omega t plus phi, in this given mathematical form, Vm represents the amplitude of the sinusoid, and omega represents the angular frequency which is to be expressed in radian per second, and phi indicates the phase. Phi is the phase, and overall omega t is the argument of the sinusoid. Omega t is the overall argument of the sinusoid. If I draw this mathematical form, this is the mathematical form, right? Mathematical form. In graphical representation, the waveform will look like this. V of t equals to Vm sin omega t. I have drawn in the form of a graph. In this context, the peak value represents the Vm, amplitude plus Vm, and this negative peak represents the minus Vm, and 2Vm represents the peak to peak value. 2Vm represents what? It represents the peak to peak value. Clear? And on x-axis we have taken the omega t, right? And if it is sine omega t, sine 0 is 0, it will have a minimum value at 0, and it will have maximum value of sine. We will come across at 90 degrees, sine 90 degrees, sine pi by 2. We will get its maximum value, right? Again, at 180 degrees, sine 180 degrees, it will cross 0. Like this, you have to understand. Clear? For the mathematical form, V of t equals to Vm sine of omega t plus phi. Vm represents the amplitude, omega is the angular frequency, and omega t is the argument of sinusoid. This is graphical representation, very very important. This is the mathematical form. Clear? Yeah. Now, from this we can observe that if the sinusoid repeats itself after every t seconds, okay, then that capital T is called the period of the sinusoid. It is called the period of the sinusoid. After at what point of time, again you are going to get the same waveform. It should get repeated. It should get repeated after that time period t. For example, observe, dear students, if I have drawn a graph like waveform like this, for this is the waveform. For example, if I have given here 1, 2, 3 and 4, and this is the time axis, and this is some v of t, let it be. You can say confidently that after 2 seconds it is getting repeated. Time t is in second, right? Then from here to here, this represents the time period capital T. Why? Because after 2 seconds again we are getting the same waveform. But if I ask the time period for this kind of waveform, observe, this is on x-axis, you have taken the time t in second, and let this one be on y-axis some v of t, and this is 1 second and 2 seconds, 3, 4, like this. For this waveform, you should observe from what point of time onwards again we are getting the same waveform. The common mistake most of the students will do is, for this waveform, if I ask the time period, they will say immediately t equals to 1 second. This is wrong, because from what point of time again you are getting the same waveform? Up to there, up to that extent we should consider it as a time period, up to here. Now what is the time period? Capital T equals to 2 seconds. This is important. For such kind of waveforms, students will answer very easily. T equal to 2 seconds they will tell. Capital T equal to 2 seconds. Good. But if such kind of waveforms are given, you should observe from what point of time again the same waveform is we are getting. Up to there we have to consider. Up to there we have to consider. Clear? Yeah. Now it repeats itself every t seconds. So time, already we know that omega t equals to 2 pi. Omega t equal to 2 pi. Now capital T equals to 2 pi by omega. Capital T equal to 2 pi by omega. Next thing is, let me see that derivation. V of t equals to Vm sin omega t. If it is to be periodic, in the place of small t, substitute small t plus capital T. But already we know that capital T equals to 2 pi by omega. Now expand Vm sine of omega t plus 2 pi. But from trigonometric basics, we know that sine of 2 pi plus theta equal to how much? Sine theta. Very, very important. Sine of 2 pi plus theta is equal to sine theta. Based on that, sine of omega t plus 2 pi, now it becomes Vm sine omega t. But from the first step, this represents nothing but V of t. Therefore, we can conclude that our V of t is same as V of t plus capital T. V of t plus capital T. Clear? V of t value is same as V of t plus capital T. Then it represents a periodic waveform with period capital T. With period capital T. Time t equals to 2 pi by omega. Okay. Next. For example, a function, a periodic function satisfies f of t equals to f of t plus nt for all for every value of t and for all integer values of n. Now very, very important thing is, if somebody asks you, oh, what do you mean by t, simply you should say number of cycles per second. Number of number of seconds per cycle. Number of seconds per cycle. But what about frequency? 1 by t. 1 by t represents number of cycles per second. Then that is called frequency. And we will express the frequency in H. He or Tz. H. Therefore, dear students, it is very important f equal to 1 by t. Small f equal to 1 by t. The units are H. But what about omega? Omega equals to 2 pi by t. Just now we have seen 1 by t equals to f. So omega equal to 2 pi f radians per second. Omega equal to 2 pi f. So these are all the basics for a sinusoid. You have to remember the amplitude Vm, frequency f equal to 1 by t, and angular frequency omega equal to 2 pi f radians per second, right? And phase phi. Here the time period capital T, you please remember these two diagrams. For the first figure, capital T is 2 seconds. For the second figure, capital T, time period is 2 seconds. You should consider up to the point of time from where again the same waveform gets repeated. Up to there we have to consider, right? Yeah. If it is periodic, V of t equals to V of t plus capital T. These are the basics. Now let me apply all these basics and find out. A mathematical form is given like this. V of t equals to 12 sine of 50t plus 10 degrees. Now what is its amplitude, phase, period and frequency? In this simple problem, all the 4 basics are covered. Right? Yeah. First of all, write down its mathematical form. What is to be written? Mathematical form. What is the mathematical form? V of t equals to Vm sine of omega t plus phi. This is very, very important. Now, in this amplitude is Vm. Compare. Vm is 12. So amplitude is how much, dear students? 12 volts. What about phase? Phi. Phi equal to 10 degrees. Just compare the given equation with its mathematical form. Right? Yeah. Now omega is known. Omega is how much? Omega is 50. But what about period? Period capital T equals to time period capital T equals to 2 pi by omega. 2 pi divided by what is omega? 50. So it is 0.1257 seconds. Now we want to know its frequency. Frequency f equal to 1 divided by t. 1 divided by 0.1257. We will get 7.958 H. This is how to find out for a given sinusoid, right? This is how to find out for a given sinusoid the amplitude, phase, period and frequency. Clear? Yeah. Next, let me understand now the phase and phase difference. Phase and phase difference. Dear students, let you consider two waveforms V1 of t and some V2 of t, and the V1 of t is starting at the origin. It is getting started at the origin. So V1 of t equals to Vm sine of omega t. And now observe this second waveform is there. V2 of t, it is getting started at somewhere. It is delayed. It is occurring early by some phi. If you observe, out of these two waveforms, which is occurring first, you should say confidently that V2 is occurring first. The starting point of V2 occurred first in time. This is very, very important. Because of this, what we say is V2 leads V1 by phi. The voltage V2 is leading the voltage V1 by how much angle? Phi. If you want to say it in another manner, if V2 is leading V1 means V1 is lagging V2 by phi. V1 is lagging V2 by phi. For example, now observe, dear students, these two waveforms. This is some VA. This is VA. But VB is occurring here. This is VB. So VA started early and VB started lately. By the difference between VA and VB is there is some angle phi. Now this is the phase difference. But in this diagram, VA occurred first. VA occurred first. VA has started first. So in this example, you should say VA leads VB by how much angle? By phi. Very, very important. Or. You can tell the same statement in another manner. VB lags VA by phi. Very, very important, dear students. Clear? The key point is which occurred first in time. That one will be the leading. The second one will be the lagging. Now, special case. Observe this diagram. In this diagram, V1 of t starting at the origin. V2 of t is also starting at the origin. Both the waveforms started at same point of time. Is there any difference between these two waveforms? No. Then we will say these two are in phase. Is there any phase difference between for this graph? Is there any phase difference between V1 and V2? No. Phase difference is 0. Phi is how much? Phi equal to 0. Both difference between the two waveforms. Both occurred at the same time. Observe in figure A. V2 occurred first. V2 started first. So V2 leads V1. In figure B, VA started first. So VA leads VB. In figure C, both the waveforms started at a time. The phase difference is 0. These basics are very, very important. Do you understand? Right. So this is about the phase and phase difference. This is about the phase and phase difference. Graphical representation. Clear? Yeah. Now, some basics are important, dear students. Some mathematical basics are important. Sine of a plus b. Of course, you know these basics. We have come across in trigonometry, but just I will recollect while doing the problems. These are required. Sine of a plus or minus b equals to sin a cos b plus or minus cos a sin b. Cos of a plus or minus b, cos a cos b minus plus sin a sin b. Clear? And you remember this diagram. On x-axis, on positive side, you take cos omega t. On negative side, you take on a negative x-axis side, you take minus cos omega t. And on positive y-axis, you please take minus sin omega t. And on negative y-axis, please take sin omega t. Based on this diagram, if you are rotating in anti-clockwise, please give plus 90 degrees rotation. You are rotating in the anti-clockwise. If you are rotating in clockwise direction, you please give minus sign. Very, very important. Anti-clockwise, please give the positive sign. Now, how do you remember this? Cos of omega t plus 90. Cos of omega t plus 90 will give you minus sin omega t. Cos omega t minus 90 will give you cos omega t minus 90. Just I will remove the signs of what are the axes. The key point is while rotating in the anti-clockwise take positive and clockwise take negative. Yeah. Cos omega t minus 90 is sin omega t. Similarly, sin omega t plus 90 degrees cos omega t. Sin omega t minus 90 degrees minus cos omega t. Similarly, cos of omega t plus or minus 180. Cos omega t plus or minus 180 is minus cos omega t. Sin omega t plus or minus 180 is minus sin omega t. These basics are important. Please take down, dear students, these basics in your notes. Clear? Yeah, this is all about the representation of a we have seen the phase difference representation of a sinusoidal waveform. The important parameters are its amplitude, phase, frequency. This example is you remember these diagrams, you take down in your notes, and this small simple example will clarify so many doubts. Vm sin of omega t plus phi. From this you should be in a position to tell the amplitude, phase, frequency and period. You please practice this example and also understand the difference between the phase and phase difference. Observe which one is occurring first. In A, V2 is occurring first. V2 leads V1. In diagram B, VA is occurring first. VA leads VB. In diagram C, both are starting at a time. Both are in phase. Clear? Yeah. So this is all about the representation of a sinusoidal waveform. Thank you.